all, Mrs. Aren't here. This is your Core Math 2 Week 4 Lesson 1, and it's all about using trigonometry to find a missing side of a right triangle. So before we get started too far, the first thing I want to talk about is if you're using one of the graphing type calculators, we need to make sure that the mode we're in is in degree mode. So on the graphing calculator, it's next to your second key. It says mode. If you click on that, it brings up a screen, and about the third or fourth line down, we need the blackened out part to be on the word degree. If it happens to be on radian, just arrow down, arrow over, press enter, and then make sure that the word degree is the blackened out word. And then you can hit second and mode to quit out of there. And you only have to do that once. If you're using the calculator on Delta Math, it's already in degree mode, so you're good to go there. All right, so using Trig to find a missing side. So if you haven't watched or gone through the videos about SOHCAHTOA, that's something you definitely want to go back and do, because that's how we're going to find these missing sides. So just a quick reminder that the sine of an angle in degrees is equal to the opposite side of the triangle over the hypotenuse. The cosine ratio of an angle is equal to the adjacent side over the hypotenuse, and the tangent of an angle is equal to the opposite side over the adjacent side. So if we take a look down here at example 1, we have a right triangle, we have a side length of 8, and an angle of 31 degrees. Now, we can certainly find angle V because all triangles have 180 degrees, so we could just subtract and find the missing angle. But that's not what we're after. They're asking us to find the length of WX. So we're being asked to find this side length here. And the problem is we can't use the Pythagorean theorem because we don't have 2 of the 3 sides. So this is where right triangle trigonometry really has a lot of power. So from the perspective of angle W, the angle we have that's 31 degrees, the side that is marked, the 8, that's the opposite side from angle W. So I'm going to go ahead and label that opposite. The side that we're trying to find, WX, that's this one here, that side is adjacent to angle W. It's adjacent. We don't have to find the hypotenuse. We don't care about the hypotenuse. So the 2 sides that I've marked, opposite and adjacent, those 2 belong to one of our 3 trig ratios. Obviously, the opposite and the adjacent both get used in the tangent ratio. So let's go ahead and set up this equation. Tangent of the angle, which we know the angle measure. So instead of writing W, we're going to write 31 degrees. And that is equal to the opposite side, 8, over the unknown side that we don't have. So I'm going to call that X or whatever variable you like. And so our job is to be able to solve this. So I could start by typing in tangent. So there's the TAN, tangent of 31 degrees. On Delta Math, you might have to hit the function key, and then you can locate TAN in there. Tangent. Tangent of 31 is about 0.6 ... Okay, well that's great, but that doesn't help us find X just yet. Our job is to find some value of X that when we take 8 divided by that number, it would be equal to that ratio 0.6 ... So how can we do this? Well, let's turn this equation into a proportion. Let's put tangent of 31 degrees over 1. That way we don't change its value, but we make it look like a fraction. So now we have a ratio equal to the 8 over x ratio. And we can cross multiply with the pair we have and then divide. So 1 times 8 is 8, divide by tangent of 31 degrees, and that's going to tell us exactly what x is. So 1 times 8 is 8, divided by tangent of 31 degrees equals about 13.3. So x is about 13.3. So what we're saying is that if we took 8 divided by 13.3, we would get very close to that tangent ratio that it's supposed to be equal to. 8 divided by 13.3 is about 0.6 ... It's not exact because we did have to round that 13.3. But we know that that's a correct answer. So that adjacent side would be approximately 13.3. Okay, so let's try another example. Down here in example 2, we have kind of a similar setup. Angle L is 48 degrees. This time, they gave us the side 2.8. That's across from M. And our job is to find LM. So from the perspective of the angle we know, the 48-degree angle, the side that's marked, the 2.8, that's the hypotenuse because it's across from the right angle. Our job is to find the side LM, and from the perspective of angle L, that's the adjacent side to it. On Delta Math, they all are oriented this way. The angle might move or change, but they're all oriented the same way. So now we're looking for the trig ratio that has to do with the adjacent and the hypotenuse. So if we look, the only one that uses both of those is the cosine ratio. So when we write out this one, we have to use cosine. And the angle measure is 48 degrees. And that ratio is equal to, like we saw up above, the adjacent divided by the hypotenuse. Well, this time we don't know what the adjacent is, and it goes on top. So the variable ends up on top this time. That's okay. And the denominator, 2.8. So we can solve this pretty much in the exact same way as before. So creating a proportion by putting a 1 underneath that cosine of 48 degrees. Well, because x has moved to be on top, when we do the cross multiplying, we need to start with the pair that we have. So this time it's 2.8 times cosine of 48 degrees. We're going to divide by 1, and that will be equal to x. So 2.8 times the cosine of 48 degrees. Now we can hit divide by 1, but it's not going to actually change any values. And this is equal to about 1.9 if we round to the nearest tenth. 1.9. And that's how we solve for missing sides. Start by labeling the side that we want to find and the side that we have based on the angle that we have. Identify your trig ratio, write the equation, and then solve the proportion. Head on over to Delta Math and practice these problems. Good luck out there.